Now in this first example, we can see we have this diagram. It's kind of a complex diagram. It's got four lines that are crossing each other. And our job is to look at each of these pairs of either congruent angles, or in this case a couple angles that add up to 180, and decide, does that make a couple lines have to be parallel to each other? So in A, it says that angle NLI is congruent to angle LKJ. So I'm going to mark those two angles congruent on my picture. NLI would be this angle right here. I just connect N to L to I, and that angle that I trace out when connecting those letters is the one I'm talking about. And that is congruent to angle LKJ. So I have a pair of congruent angles. The question is, are those corresponding angles alternate interior angles or alternate exterior angles? Because if those are one of those pairs, then it means that we're going to have some parallel lines. Now it can be a little bit confusing when I have this diagram where there's actually four lines. So what I recommend that you guys do is I recommend that you kind of try and look at which lines are used to make those two angles, and ignore, if there's a line that's not involved in making those two angles, try and ignore it temporarily. So if I look at angle NLI, I need this line and this line to make it. And if I look at angle LKJ, I need line NQ and line PS. So in essence, I'm going to ignore line MR right here. Pretend like it's not there. And if I do that, then I'll notice that these two lines are actually going to be corresponding angles. So there should be a pair of parallel lines. Well, they're corresponding angles for line OT and line PS being crossed by the transversal line NQ. So I should be able to say that because those lines are congruent, or sorry, because those angles are congruent, that line OT is parallel to line PS. And I'm just going to put a reason down here. It's because corresponding angles are congruent, just to kind of illustrate what the reasoning is for making these two lines parallel. Let's try the next one. Let me get rid of my markings here that I put on the diagram for part A. Get rid of all those markings. Okay, let's mark angle KJR congruent to angle MIT, And then again, I'm going to trace out the lines that I would use to make those two angles. So it looks like I need these two lines to make angle MIT, and then I need to add that line in to make angle KJR. So I'm going to pretend like this doesn't exist. I'll maybe take your hand and cover it up on your note sheet if you need to. And then you'll notice that these two angles are alternate exterior angles. They're both in the exterior space between these two lines. This one is above this transversal. Angle MIT is above it. Angle KJR is below that transversal. So that means they fit the definition of alternate exterior angles. They are congruent, so that means I should have a set of parallel lines here. And so actually, again, it's the same set that I had in part A. So again, line OT is parallel to line PS, but this time it's because alternate interior angles are congruent. Let's move on to part C. So let me get rid of all my markings here. Getting rid of all these markings. Okay, part C says that angle LIJ, so I'm going to put a mark on angle LIJ, and angle IJK, so I'm going to put not the same mark, because it doesn't say that these two are congruent. It says that they're going to add up to 180. So I just put different markings on them, and then maybe you can kind of say 180 degrees if I kind of combine them together. Sometimes I'll kind of add that to my diagram to kind of show, hey, these are going to add up to 180. Okay, does that make a pair of lines parallel? Well, again, I'm actually using the same three lines to make those two angles. So, do I have a reason to say that maybe those lines are parallel again? In fact, I do, because these two angles are same side interior angles. They're both between the two the two lines and on the same side of the transversal, and they're supplementary, then again, actually I didn't mean to make this example like this, but it just so happens that we have the same set of lines parallel because same side interior angles are supplementary. So that makes those lines parallel. Let's look at the next one. So in the next one, we are looking at angle PKQ and angle MIT that are congruent. So angle PKQ and angle MIT are congruent. Now this is the one that usually tricks people because they look at that and they think, oh, those are alternate exterior angles. They look like they're alternate exterior angles. But if I trace out the lines that I need to make each angle, so those two lines I need to make angle PKQ, and then I need these two lines to make angle MIT, what you'll notice is I don't have the situation that those theorems that I learned at the beginning of the note sheet on the I don't have that situation. I don't have two lines crossed by one transversal. I'm actually using 4 different lines to make these two angles. And since my hypothesis on that statement isn't true, I can't use that statement to make any conclusions. So even though it looks like, almost looks like these are alternate exterior angles, they're actually not. They're not, they don't fit the definition of what alternate exterior angles are because I needed 4 lines to make those two, so they're not going to be alternate exterior angles. So for part D, we actually say no conclusion. There is no conclusion that we can draw based off of this information. It's possible I have some parallel lines in this picture, but I can't say that they're parallel because of this being true. Okay? So that's part D. Let's look at part E. Get rid of my highlighter again. Part D, angle ILK, so that would be this angle right there, and angle LKP would be this angle right there. And if I look at that, and again, highlight my lines here, here, and here, oh, it looks like again I have one of those special pairs of angles that we've learned about. I have alternate interior angles, and they're congruent, so that's going to again make line OT parallel to line SP. Line OT is again parallel to line SP because this time the alternate interior angles are congruent. Now in our next example it says that angle 2 has a measure of 4x minus 6. Let's put that on there. 4x minus 6. And angle 3 it says is 2x plus 18. And we want to figure out what does that x have to be so that line A and line B would be parallel. Well, if I want line A and line B to be parallel and I'm using the information about angles 2 and 3, then that means I'm thinking of line D as my transversal. And in that situation with A and B crossed by line D, those two angles are alternate exterior angles. If those lines are going to be parallel, then those alternate exterior angles have to be congruent. I'm going to write that out. If A is parallel to B, angle 2 needs to be congruent to angle 3. So if I take the measure of angle 2 and say that it equals the measure of angle 3, that's what I'm looking for. I'm looking for these two measures to be equal. So the 4x minus 6 needs to be equal to the 2x plus 18. Now I'll go into algebra mode. I'll subtract 2 x's from each side. Now I have 2x minus 6 equals 18. I'll add 6 to each side. So now I'll have 2x equals 24. I'll divide both sides by 2. And my x would have to be equal to 12. That would make angles 2 and 3 congruent. It would make, just to kind of show you, it would make this be 2 times 12 plus 18 is 24 plus 18, which is 42 degrees. This would be 4 times 12 plus 6, which is 48 plus, or sorry, minus 6, not plus 6. 48 minus 6 is also 42. So that's 42, that's 42. My alternate exterior angles are congruent. And so if x equals 12, lines A and B would have to be parallel. And it says, what theorem justifies your answer? My theorem would be the converse of the alternate exterior angles theorem. That justifies that when x equals 12, these two lines would have to be parallel.